Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor. In today's video, we're going to be talking about the calculus topic, continuity at a point. This is one of the first difficult topics you learn in the year. It's related to limits, but it's a little bit more involved than that. And by the way, I'm going to be specifically focusing on piecewise functions in this video, which if you forget, these are the functions that have the curly brackets in them, and it has some function for one region and another value for another region. It's not always two branches. I can have 3, 4, 5 if I wanted to. But we're going to see how these piecewise functions relate to calculus, specifically continuity. So to prove continuity, we need 3 things to happen. Number 1, your value, let's say you're checking at the point C, where C is any constant, 1, 2, 10, 1 million. F of C, in other words, the Y value, has to exist. When I say exists, I basically mean you cannot have a 0 in the denominator, you cannot have a square root of a negative number. Basically, everything else is okay, for the most part. The second thing we need to have happen is the limit as x approaches our value, c. That limit has to exist. Now remember, with limits, we have a few strategies we've talked about in previous videos. For instance, we have direct substitution, which is going to work for a lot of these problems, as long as you're not getting a 0 in the denominator, or again, a negative square root. Besides that, you can use direct substitution. Or if you do get an indeterminate form, remember indeterminate is 0 over 0, then that means we have a few strategies we can use, the number one being factor and cancel. And the third and final thing, in order to prove continuity, our value, f of c, the y value, has to equal the limit as x approaches c. Now most of the time this will happen, and I'll show you an example today where this check fails. But these are the 3 things we need to pass in order to prove continuity at a point. So let's look at a couple examples together. Here's the first one. F of x equals a piecewise function with 3 parts. For the top part, I have 2x plus 5. That's when x is less than 2. For the middle branch, I have 9. That's when x equals 2. And for the last branch, I have negative x plus 11, that is when x is greater than 2. And I want to know, is our function f of x continuous at the point x equals 2? So how are we going to do this? Well, first, I just need to make sure the value exists, the y value exists at f of 2. What does that mean for a piecewise function? It means we're looking for the equal sign, which is the middle branch. You'll notice it just says 9. Since there's no x's to plug in, the answer is just 9. However, if let's just say that middle branch was 9x instead, I would have plugged in 2. I'd say 9 times 2, which is 18. But because there was no x there, I'm just going to keep it as 9. So check 1, passed. Check 2, this is the tough one. The limit as x approaches 2 has to exist. And to do that, I'm going to be looking for the left hand and the right hand limit. When it comes to a piecewise function, what that means, the left hand limit is the less than sign, and the right hand limit is the greater than sign. So in other words, for left, I am plugging 2 into 2x plus 5. That's easy. 2 times 2 plus 5. That'll get me 9. And then for the right side, that's going to be the function negative x plus 11. So negative 2 plus 11, that's also 9. Since these two answers equal each other, 9 equals 9, then that means the limit exists and the limit is equal to 9. Check mark. Finally, the third check I do, did the value f of 2 equal the limit as x approaches 2? And the answer is yes, because they're both 9. So we pass our third check. So the answer is yes. This function is continuous at x equals 2. And that's our final answer. One thing you might be wondering right now, couldn't you have just plugged in 2 into all 3 of these piecewise functions and if they all equaled the same number, then it's continuous. And if any one of these three were different, like let's just say this middle one was a 5 instead, then it's not continuous. Do I really have to go through all these steps? I'm going to tell you yes and no. Number one, yes. All we did was just plug in 2 into these three functions, and if they're all equal to each other, it's continuous, and if any one of these are wrong, then it's not continuous. That is true. However, what our teacher, professor, the AP exam, whatever, in order to prove the continuity, we're looking for these 3 checks. I promise you that. So that's why I want you to get in the habit of doing all 3 of these, because that's what they're going to be looking for to give you full credit. Now we're going to do one more example. This one's going to be tougher. It's going to be a piecewise function with 2 parts. The first one has a fraction, x squared minus x minus 6 divided by x minus 3. That is when x is not equal to 3. And when x is equal to 3, we're going to have the function just x. So the question is, how do we deal with the not equal to sign? And I'm going to tell you. When you see not equal to, that basically means it's greater than and less than. In other words, it is the right side limit and it's the left side limit. It's both of them. It is not the value of the function. That's still going to be the equal to sign. So for my first check, does f of 3 exist? The answer is yes. I just plug in 3 for x. I get 3. First check passed. The value exists. Now for the limit, remember for the limit here, now remember, since the not equal to sign means we're covering the left and the right side here, I don't need to split this one up into a left and a right side limit. It's the same thing. So I just need to take this limit once. However, if I plug in 3, I'll save you the time, you get 0 over 0, which is not a bad thing. It is indeterminate, but we have a strategy to take care of indeterminate. All I have to do is I have to factor and cancel. I can factor the numerator because x squared minus x minus 6. That just factors to x minus 3 times x plus 2. In other words, it looks like my x minus 3 terms will cancel. And I'm just left with the x plus 2. And then don't forget, for a limit, you still have to plug in the x value, 3. So 3 plus 2 is 5. Great. Not only does the limit exist, the two-sided limit exists, both the left and the right, which is great. And then for the final check, I just need to make sure the y value equals the value of the limit, which if you're paying attention, you know that is not true because 3 is not equal to 5. So that means we failed our third and final check, which means we are going to say not continuous. This function is not continuous at x equals 3. And so hopefully you have a good idea now of how to deal with these piecewise functions and continuity at a point in calculus. If you do have any questions, please write them in the comments. Have a great rest of your day, and I'll see you in the next video. Take care, and bye-bye.